Welcome to class 3. Let's now understand how to analyze unstructured customer feedback. Let's really dive into lesson 1. The methods for categorization. So there are basically 3 and we will discuss all of them in detail. First off, manual coding. Manual categorization is a human sits down, looks at verbatims, the text response, and basically categorizes, puts it in buckets. Second, unsupervised categorization means using unsupervised natural language processing, unsupervised AI, or whatever you may call it, or vendors call it. It's basically a method where you upload your text. It does a bunch of magics without even you know about it, and it gives you categories. And supervised categorization, supervised text analytics, supervised NLP, whatever you call it. It is called supervised because a human teaches the system, a human teaches the artificial intelligence to categorize. These are the three things you need to bear in mind. Each of them has pros and cons, and let's discuss them. That's how typical manual coding looks like. You have all your verbatims. Yeah, you may even have the NPS score next to it. And when you start off, you will start to develop codebooks. This means basically there are different categories where the verbatims may belong to. So once you start coding, you add one or another category to it. In this example, it differentiates between positive and negative categorization. Every code gets a code number, and that's basically how it works. In reality, it's a piece of Excel. Yeah, you have some rows because customers talk not just about one topic, they talk about many topics. So you may have several columns, and you basically, the coder goes through, and for the most frequent used topics, they know the codes in their mind. So quality is always whatever, 10, and they already type it in. It's super fast for them once they have learned the code, and that's how it goes. Yeah? They go through all your hundreds or thousands or 10,000s of verbatims one by one and try to categorize it. That's a process. And what some also do is trying to judge on the sentiment. We will discuss this in more detail later. In this case, sentiment means how emotional this response is. Is it super emotional, or is it just positive? Right? That's also what you can do, human coding it. And once you have coded that, you can start counting, right? How many people are saying price is too high? That's manual coding. And of course, there are lots of do's and don'ts, which we will discuss in a minute. Second, unsupervised learning, unsupervised AI, unsupervised text analytics. Again, you just take your data, upload it, and just by magic, it comes up with a bunch of clusters. It comes up with a bunch of different categories. So basically, it clusters verbatims or pieces within verbatims to each other, which sounds kind of similar. There are, of course, different techniques to do that. But what you get this is an example of what you get. And of course, there are differences between the technology and the vendors. But what you see is that oftentimes it's quite vague, and Oftentimes it seems to make sense, but not always. Yeah, and you have still some parameters where you can basically say, you know, give me just 10 categories, don't be so specific, or the opposite around. But basically there's no way that you teach the system, because otherwise it would be a supervised learning system. So this is an example of a supervised learning system. Yeah, you have here examples, so the verbatims, and then you start coding it. Yeah, instead of you can start here in the software, put the numbers, like it's like manual coding, right? You have a drop-down menu, and you can pick and choose. So this is especially good when you have large code books and it's really hard to remember those numbers. You can be quite fast with software help. And also it helps you to manage descriptions. So sometimes it's not enough to just read the label of a categorization. You would like to learn in more detail what is really meant by this categorization. And the software also gives you a validity score, so how precise is already the model learned. Because basically you start teaching the system, but after a few hundred examples, it will pretty much be as good as you. So it can categorize the rest for this time being, or even for the future. The beauty here is that in contrast to manual coding, we basically start with a list which has a random order, yeah, and you start coding it. And typically there are some topics which pop up frequently. Yeah? So basically every second code is the same, yeah? Or every second verbatim reads quite similar. So it takes a lot of time to really arrive to a topic which is seldom. And this is different with supervised learning, because supervised learning can help you to detect if it is already good at understanding quality. It will not show you quality anymore when it's mentioned. It shows you something different. So you will be much faster in really teaching this AI to understand, to categorize everything. Another example, also advantages with such a system, it's much better to manage huge code books. So this is an example of 150 codes. And actually this is hard to bear in mind. But with the software it's much better, because you can quickly find the codes and again read the definitions. So it is easier to become consistent. Also, the system can help you to really understand where you need to become better, because these are example codes where basically the thick slices, they are often mentioned like this, yeah. But if it's below the circle, the validity is not so good. Yeah, so this is very important to work on. There are other topics where you're also not very good at, but they are very seldom. So you can really look at which codes are already trained well, and then try to find new ones or revisit what you have coded. So this gives you guidance to detect your own errors, which is not possible in manual coding. Good. Lesson 2, building a codebook. So manual coding and supervised coding requires the human to build a codebook. And there are some do's and don'ts around that. Of course, there it depends on the use case. But in general, the recommendation is be granular and think about actions. So it's not enough to have a code which is correct. It should also be useful. Yeah? And it is useful if you are more specific. Yeah? It's okay to categorize something as poor quality, but it would be good to know how to improve this quality. And oftentimes people not just talk about the quality, but maybe the software has bugs or it's slow, whatever it is. So granularity is king. And granularity translates into actionability. Always have codes with a direction. This means actually the code itself has a sentiment. Why? You know, you can of course have codes like price, quality, but actually when people read it, they really don't know how to understand that, right? When building categories, always construct them that they have a direction. So bad pricing, bad quality, good quality. Because in this way, first of all, everyone who reads it understands what it means. When you say quality, price, service, yeah, what is it? What about? If you really need to triangulate that with a sentiment, it becomes exercise. So, and also later in analysis, this even enables you to detect nonlinearities just by having direction-based codes. They are basically more specific and are later on easier to to recommend actions on them. Be mutual exclusive. This means make sure that when you choose a certain category, the other one can't be the same. Of course, if someone says someone says friendly service, this is not mutually exclusive with great service. But this is not what I mean. I mean is that one specific verbatim can belong only to one category. There is no doubt whether or not it belongs to. And if you are not clear, really write a description, write 1 or 2 sentences, what it is and what it not is. So the second part is also very important and helps the coder to remind them what really is the meaning. And if you can't really describe it, then it's probably not a good code. So then lump it together. Cluster categories in category groups. Yeah, so you have a hierarchy. This enables you to have overview summaries and to have a broader look at. So basically the category and the child, some people say call it the child or the topic. This is what is taught to them, and this is what you train and what you categorize, and they can be grouped, but the core, what you train, is the child or the specific category. When you label that, try to be specific. Yeah, typically we tend to use some general terms so it matches everything, but this typically leads to the fact that it's hard to understand. So really use the language of the customer. If they say these guys are dumb, that's probably a good way to phrase it, right? And you may try to be polite or whatever, but always be most descriptive and specific and use the language the customer use for two reasons. First, you will be better understand what it means, and the AI understands it better too, because the latest AI is not just uh, grouping or finding those who belong to a group together. They really look, what's the label of the group? Yeah? What does it mean? Does it really associate it to the content of the verbatims? So that's why the label itself is important for supervised learning. Sometimes, yeah, as I said, you have certain categories and they don't really differentiate between each other. Maybe brand, great brand, a reputed brand, something like that, which is for, as a customer view, hard to differentiate it to. Then you may want to say great or reputed brand. And then it's again important to use and or the right way. Yeah? And means the customer mentioned both, or means he mentioned one of them. That's important to give basically the person who reads the label as well as the AI the correct guidance. What's very much used are other categories. But actually they are, the only use of it is to counter how much do we not specifically categorize. But actually this should only be used for manual coding, because there are again two reasons for that. First off, you risk to confuse the AI because it's such a broad thing. Basically, Asos is basically everything else, but the AI is trained to find something as link between something to something specific others. Yeah, so, and the link from something to everything except this is not what the machine is trained about. And when you do that, it may work somehow, but you will not be able anymore to leverage the feature where the category or the AI suggests you topics he is not able to understand, because those things will be typically others, right? But it's super important that the AI knows what it doesn't know. And this can only be managed if you do not use another category. Then there are categories, let's call them non-informative categories. These are categories like which you say this doesn't belong to our codebook, which typically customers may say, I gave a 0, yeah, because I don't recommend in general. Typically, I'm very satisfied, but I don't recommend, so that's why I gave a 0. That's basically what 10% of insurance companies, company customers saying. So you may say, this has nothing to do with my product, right? But still, it's important to know it because it's an explanation why your NPS is like it is. Yeah, so that's typically very interesting that you include categories that doesn't belong to the typical buying criteria, because it helps you to explain the outcomes. So then there's the question, what's the minimum frequency of a category? And this depends on the usage. So basically this is something you need to decide. You always start with no limits. Yeah? You always build categories once they pop up new. You open a new category if it's mutually distinctive to something which is already mentioned in the other categories. And at the end of the exercise, you can still decide to skip some of those categories if this is helpful. This was lesson 2.
Lesson number 3, finding new categories. So if you do a new wave, it might happen that new categories, new topics popping up. So you need to deal with that. You need to enlarge your code book, and the question is how you do it. So in manual coding, you need to basically go through all new responses and try to find the new categories by hand, or you code everything which doesn't fit the codebook into others, and then you revisit the others category and try to find there a new category. For unsupervised learning, actually unsupervised learning always finds new categories, but on the other hand, it changes the definitions eventually of the old ones. So if you find a software which can fix the old ones, it may be able to find new categories without changing the old ones. So unsupervised learning is basically does this automatically. Supervised learning is again trained by a domain expert. So it needs a human to find the categories, but there's a trick which tools have implemented. The trick is called smart sorting. So actually it sorts all new verbatims, so the new waves comes in and it's sorted, and at the top you will see those verbatims where the machine says, you know what, I don't have a clue which categories this belongs to, right? And obviously, if the AI haven't learned something, it's probably, yeah, it's new, yeah, or it's others. It's another reason why you should not have an other category, yeah, because then the AI knows what it is. It's others, right? So this way, if you use this feature, you can find new categories very easily with little manual work. Lesson number 4, manage consistency. That's very important, that the categorization you're doing means the same last year and this year and the year after. So let me explain where's the problem. So first off, in unsupervised learning, again, the default is it retrains, it basically finds categories new, and basically it will not be consistent. So this would mean don't retrain it. Eventually, software will appear in the future that allows this fixing the definition of the old categories. So in this sense, it will stay consistent. Consistent also, of course, means it doesn't learn anymore. It cannot change. It cannot get better in case it was not perfect beforehand. So then manual coding, how we manage consistency here. First off, the biggest problem is the personnel, is the human. And if you change, the human will make errors or will code a little bit different than the other one. Yeah? Coding, when you try to categorize, the human went into a learning process. Yeah? It will start code different in the beginning than at the end. And the same learning curve will have another person eventually a different other learning curve. So that's why one important thing to manage consistency is to stick with one person, if possible. So, and when you need to change it, so you need to really think of intensive handover. So intensive training, what exactly the code means. The gold standard actually is to always code in teams. So always have two person categorizing the same stuff. And then you have the option and you have the ability to really validate yourself. Yeah, if there is no little overlap or at least some discrepancies, you know that you have a problem you need to improve. Then you can talk about it. So that's of course double costs, but this is for manual coding the only way to really figure out whether or not what you're doing is right. One thing you can of course do is use supervised learning as the second coder. Yeah? If a person trains the AI, this AI will be the second coder, which can then basically be the wingman of the coder. Explicitly maintain category definitions. So that's very important that you really write down what is a verbatim which belongs to the category and what is a verbatim which does not belong to it. Keep your code book smaller than 100 codes if possible for several reasons. The main reason is actually that coders have a hard time to really find the right code. So typically you have most of them in your mind, but if you have 200 codes, you have a big list and it's cumbersome, you get lazy, and also you forget. And this leads to errors. So the larger the code book, the larger the likelihood that you will make mistakes when categorizing. So for supervised learning, actually the same applies because the training process is manual coding. Yeah, with the difference that you can really focus on quality coding because you don't have to do so much. Yeah, make sure you really train the machine right, so it will consistently being correct. Right. So same as manual coding, and each time you train the AI, it might be slightly a different model. That you need to be sure that, of course, training and the retraining, yeah, if you have a new wave, you retrain it, it will be different. So consistency will be lower because it will be better. Yeah, then the next wave, it will be more precise. You retrained it. So that's what you need to think about. Is this okay that I improve? And this is why the consistency is lacking or not? If not, you need to perform a backwards categorization and calibrate the past verbatims. So basically what you do is you train the new AI, and then you take all the past data sets and feed it through the new model. Then what you will see is, of course, that the frequencies and the categorization of the past are a little bit different. And basically, you can adjust, recalibrate the frequency scores. You can basically find the factor, yeah, so that basically the frequencies of the past stay the same, and you simply find the recalibration factor for the new wave. That's what you can do.
Good. Lesson 5. Dealing with multiple languages. So if you're an international company, you have multi-language feedback, right? And the question is, how are you dealing with that? How are you categorizing it? So, of course, the first thing in mind is, of course, we need native coders, native people who take a look and categorize, right? Because that's the best thing you can do, because they are the best source to really understand what the verbatim means, right? So the question is, or the challenge is here, how do you make sure that the categories really are not only the same, but are understood the same? And there are some differences in languages. Yeah, there are some words in German that doesn't even exist in English, and the other way around, right? So it's basically impossible to have 100% match of understanding between categories, between languages. That's the truth. That's why the whole exercise of using native coders, I would not recommend it if you have more than 3 languages, because those native coders, they need to communicate. They need to make sure they understand all categories the same way. And the alternative approach is actually taking the verbatims and translate them, auto-translate them into one core language. You might say, oh my God, I lose a lot of information with that. So you may know Google Translate and you may not be 100% satisfied. So yes, you lose information, but you have one understanding of categories, one native coder categorizing everything. And there is tech available that is better than Google Translate. So we are using Deeble.com. It now supports 24 languages. It is basically based on testing. It's clear it's much better than Google Translate. So if you have multiple languages, more than 3, this is a way to go, because to my experience, this gives, at the end of the day, much better results. Lesson 6, sentiments. So as a sentiment, typically people understand whether or not a comment, a verbatim, a text feedback is positive or negative. Strongly positive, strongly negative. That's a sentiment. But there are other understandings of it. That's important to understand, because actually if you build a code book like I just suggested, you already have the sentiment, right? Because it's part of the code. Good quality, bad quality, right? You may miss the intensity eventually of it, right? So sentiment is an inherent part of a category definition. But you can understand sentiment also in a different way. And this really depends on what kind of sentiment algorithms you are using. And I would recommend to really challenge your vendor or the provider, so you really understand what the sentiment means. Yeah? And I can already talk about that. Sentiments, which basically understand whether or not something is positive or negative and how much, we don't see that having predictive power to outcomes, because we already categorized the verbatims into segments, and these are typically strong enough. But what can have predictive power, so basically, which is important to look at, are sentiments which measure the tonality of the command. What do I mean by that? The tonality is this. Here's an example. your great product X, it can be even improved by a smart feature like if you do this and that. So the whole language is positive, yeah? They love the product and they're missing a feature. Yeah? So it is a negative command, but it's very positive, right? So with a conventional sentiment analysis, you would not miss it. So tonality type of sentiments are a different kind of sentiments which are very useful. Another types of sentiment is emotional coding. So there are APIs you can tap on, and some software have used them. It's basically to categorize to which emotions certain verbatims belong to, and what probably the emotions are which triggered those verbatims. Yeah? Typically, you see emotions like from the 7 Ekman emotions: happiness, surprise, fear, anger, disgust, sadness, and so forth. So this is something which might be interesting, but it is quite limited to this information, and there are other ways of categorizing it. One very interesting way is so-called associational coding. So there are AIs which can be tapped on, for instance, NeuroFlash is a tool like that, that finds which other terms the verbatim is associated with. Yeah. So, for instance, if someone says straight to the point, your service is crap. Yeah. Just starting straight to the point is associated with the term dominance. Yeah? It's a very masculine way of look at that. Let me be clear here, right? So it's a dominance statement, and this kind of AI can detect on a dimensionality of many hundred of terms what your verbatim belongs to. And that's very interesting when you actually use verbatims which is collected in the branding space. Yeah? Then you can really look behind the words and see its meaning. Good, that's about sentiment. General sentiment already categorized. Very interesting sentiment in terms of tonality. There are other new ways of looking at it: emotional coding and associational coding. So now let's validate our categorization. That's very important to understand. Is the categorization correct? So, and there is a trick. Yeah, that's a trick which some, especially consultants, actually use. They brag with high hit rates. When actually hit rates must be calculated the right way. For a simple reason. If you want to calculate whether or not your text analytics category is correct, you could look at the hit rate. And basically, if you are categorizing none of your verbatims, basically the verbatims belong to none of your categories, then your hit rate is 99% or 98 or whatever, but very high. Why? Because you can be very sure that the likelihood that one of your code books is within one verbatim is very small. Yeah? If you have a category which is frequent, it is 20–30%, but typically 90% are even lower than 10%. Yeah? So that's why the best guess is to say doesn't belong, right? And this way you can basically have a fantastic accuracy, but this doesn't mean anything. Yeah? What you need to look is at this grid. Yeah? Something which is in truth belongs, for instance, is quality. And if it's predicted as quality, it's true. Right? If it's then but predicted as something else, or basically not as quality, then this prediction is wrong. This is a false positive. Yeah? This is error number one. The other error is basically if it's not quality, but you predicted as that it is quality, that's a false negative error, type 2 error. And you can sum up this with a so-called F1 score, which just basically takes everything, weights it with its frequency, and comes up with the right measurement, so you can really compare the quality. That F1 score is really the gold standard score used in science to measure categorization. So make sure you select a vendor which can compute that. If you do it manually, there are certainly ways to use a Python library or Excel plugin to compute that. Then there is another thing in terms of validity, because the F1 score only measures if what you're doing is consistent. But you're not sure if it's correct. A funny story, we had a project and we wanted to compare old, or basically the approach an agency was using to categorize the verbatims. We wanted to compare that with a modern approach of supervised learning. And they gave us their categorized data. And we took this data, basically a part of it, trained the supervised learning with that. And it was 90% or 95% consistent. This is very high because when basically human code things, you will find an F1 score of 70 to 80. That's human possible. 80. But 90, if you are above 90, you should be suspicious. And actually, it turned out that they used algorithms, rules, every time there was pricing, or the word pricing, it came up in the pricing bucket. So in this way, because of the rules, it was very consistent. Because they managed also to build the categories that way. Basically, they defined it wrong. But they had a good consistency. So, but at the end of the day, what you want to have is a true categorization. And actually the truth can be best found by finding whether or not it is useful to predict outcomes. Something which has described us through the category, if this something has an impact in this world, and that's why we categorize it, right? We categorize it because we think it's important to drive outcomes. If this can predict outcomes because it was some kind of important, then it's probably correct. And that's also the whole philosophy behind the Granger causality, but we can discuss this later. But given that, yeah, the final litmus test of the truth of your categorization is actually its predictive power to predict and understand outcomes. So the R square of everything you do toward outcomes is the final measurement of whether or not your categorization is great. We even compared the different categorization schemes. It's maybe 2 years ago where we took lots of data and tried to compare unsupervised learning with manual coding, with supervised learning, and we took it to the predictive power test. And unsupervised learning achieved an R square of 0.4. And we use open source supervised learning, which was already much better, much more predictive. So it was more true. But it was not even close to manual coding at that time. So, but we tried further and found a supervised learning approach, which we call here benchmark supervised learning approach, that even exceeded the predictive power of manual coding. So there's a big difference between different approaches, and the field is evolving every day. But it is important to test its power. The best is actually to validate its predictive power. And you may ask, yeah, why can a machine be better than a human? So it might not always be better than a human, let's put it this way, but there are some advantages. First off, you have seen that the training of the supervised learning is augmented, so the trainer itself becomes better by training because he gets feedback from the machine. Then actually the sentiment of the machine is better than the sentiment of a human. Yeah? Sentiment mean this kind of column where the coder says, oh, this is very emotional, yeah? Or this is not very emotional. And actually, when it comes to the tonality, this is what the machine can detect much better. It is trained on billions of Amazon ratings and can really find, obviously, much better, much more predictive, the tonality of the verbatim. And also, the machine tells you what if it is uncertain or not. The coder is never uncertain. He says, okay, this category, this category, this category. It's not his task to assess, I'm not sure, right? But the machine can tell you that. And with this information, whether or not something is sure or not sure, it can also be predict better. So these are some reasons why supervised learned and categorized data can be even better than manual coded data. So let's wrap up with this class 3. There are 3 types of categorization: manual categorization, unsupervised, and supervised categorization. There are some do's and don'ts for categorizations and building the definitions of the categories, especially also for the label conventions. It's important to build granular code books, to label it very specific, and to avoid other categories. It's important that you always be on your toes to detect new categories, and you learned things how you really make sure you are always learning wave after wave. We discussed that managing consistency is very important. This means make sure that the categories mean always the same thing. We discussed how to deal with multiple languages, and typically if you have many languages, it's the best way to auto-translate everything to one language and keep a consistent management on this codebook for this language. We discussed sentiment, and that are many different ways of producing a sentiment, and that actually the final judgment of whether or not the sentiment is useful is its predictive power. Very important to always assess the validity of your codebook, the validity of your categorization. And this is done by the F1 score to really balance the different hit rates, but also to look at the predictive power of those categories. And only if you improve the predictive power of your data, you improve the truth of your categorization.